After knowing the outer function that we checked in the previous video, now it's the time for an adventure with our visualization. The example that we are going to do together is the one that I chose because I want to impress you with the power of R in visualization. And remember, it is the general power. There are still another more advanced and special visualization packages in R. But here they are just general functions, and as I told you, I have chosen this one to impress you because the visualization that we are gonna do together in a minute uh, is the one that you cannot do easily with the other softwares, or it is not the one that quickly you can say, okay, I could have done it with Excel. Why should I go through all these difficulties for that? It is three-dimensional plotting. So the example that we are going to do together is three-dimensional. And it is very easy. So please, if you have any question, feel free to reach out to me. And since the video is recorded, my friend, you can repeat and recheck it 10 times until you dominate completely on the concept. Okay, the visualization function that we are going to do together is persp, that is perspective. And since it is three-dimensional, we have x, y, z. Very easily, you can visualize this if you give these things x, y, z to persp, and you have your plot. Here you see more description about the plot, but if you remember, it was several sessions before, I guess, when we were talking about data frame, and I emphasize on the fact that if something at the first glance seems complicated, just start it simple. So you see there are many options that you can set regarding these function, but we are gonna do it simple and just with x, y, z, and as much as time allows us today, I'm gonna use these things for you to see how much they are user friendly. Okay, uh, the plot that we are gonna do is this plot: z equals to x to the power of 2 plus y to the power of 2, while the ranges of x and y is -2 to 2. We get it small so we can focus on our R discussion more. You remember from high school, you remember from general math that you had in the university, that whenever you want to draw something, plot something, you need to define a range. For example, if it is a two-dimensional plotting, what does it mean? It means that you specify the on x-axis something like this: -2, -1, 1, and 2, and after that you assign the dots that you have, points, and you connect them together. It is exactly the same thing, my friend, but we are going to do it in a three-dimensional space that for most of you it is the first time you are trying to plot a three-dimensional, because you are working with a programming language, and it means that now you can communicate with computer has huge computational power. So since you know how to communicate with your computer, you can do things that are with computer super easy, but without computer super difficult. So we are going to plot these things. And the interesting things is that when you know how to do all these things, you don't need any knowledge of mathematics to be able to plot this three-dimensional function. You just need to know the general rules. Okay, so remember this, z equals to x to the power of 2 plus y to the power of 2 in this range for both x and y. And remember, we are going to using the function outer. So if you think you are not good with function outer, stop the video here and go back to the outer function exercises, do them, recheck them, replay them until you are good with them. Same as other plotting that you have had so far, first you need to specify the amount of inputs that here are x and y. Since it is three-dimensional, it is not only one rows of x or y's. You need to define them, you need to specify them simultaneously before you apply your function. So here I'm gonna do it x. I'm gonna use the function sec that today we learned together. As it was specified in the question, it is between -2 and 2. And here it is up to you how many points you want to locate and assign in your plot. I'm gonna put 100. I can put any other number, but here I'm gonna put 100. But while you are practicing this at home, dormitory, library, try other numbers and see the differences. And at any point, if you find something that doesn't make sense or like that, please let me know. Okay, so with this command, I define x, and the same thing for y I'm gonna do. So I have these things finished. So I have x and y now defined. The other things that I need to define is z. And if you remember, z equals s square x plus s square y. So here I need to define the function. I put the name of 1 for the function, because you remember we had a function and we learned function last week. So here we have function. The inputs for the function is inputs are x and y. And here I put the function over 2. Programming, any programming language is very connected, has a very connected nature. So that's the reason I always ask you to keep caught up, because in that way learning would be much easier for you. So you see function related to the previous topics that we had. And here outer is related to just previous video. And if you know the previous things well, you should be fine with this. Okay, now as you can see, we have of 1 equals function x, y, and after that, here it is the output. And here we are good now, and after that, we are good to define z. So remember, first we define x, then we define y. After that, we define the function that we had. So far, very regular things. For example, if you are given a task to draw, plot a thing, just check the range and check the function, and after that, calculate the numbers, values for z. That you are gonna make it like this. Outer that we have, in outer we have x and we have y. And we have, what is the function? The function is of 1. And that's it, my friend. Now you have z. So when you have these things, now you can go for your function that we are gonna do in the simplest way possible. I'm gonna put x, I'm gonna put y, and I'm gonna put z. X from here, y from here, and z from here. So let's run it line by line. to see what happens. It's okay. And after that, now I run this function. And after that, I run Z, as you can see in the counselor, the counsel. I guess several times in the previous videos I said counselor. I'm not sure, but I just said it's counsel. Sorry for that if I have made that mistakes. Okay, now we go for press. Just see the plot that we got. Quite a sophisticated plot that you see. It is three-dimensional. How much easily all the mathematical aspects of this plotting handled by R, and we just write down the formula according to syntaxes. If I want to show you in the another way, it is gonna be the plot that we have. Okay, so please, my friends, while you are doing it at home, since you have more time than I have here, try it with other numbers and see the results. Now it's good to go and check some other options from the PowerPoint that I showed you. One thing that first I want to show you to impress you more about the power of R in comparison to the other things is going with theta and phi that sets angles for the plot that we have. So let's go for theta and see what happens. And as you have learned, and as I have emphasized many times, this to you, for you is this. Always start simple, and when you could run it simple, and after that start making it more and more sophisticated. And now I go for theta. Let's see what will happen. Many details could be changed about this plot, and remember we just started. Okay, here I go for theta, and you know that how we always do this. We put the name and we put the value. Here I put the value of 30. Okay, when I put the value of 30 and I run it and just check here the changes that happens. You see, my friends? Now it shows you this plot from another angle. I change it to 60. You see, now it is rotating. And you can change it also another, you can rotate it around another axis. Okay, so we go for another one. We go, for example, for phi, and I change phi to 30 and I run it. You see, my friends, the changes. It is like over there is a camera that goes and check this three-dimensional plot from different aspects. I make it 60. And you see, now we are over there. Okay, and since you have more time, please try it from different perspectives and enjoy the power of your computing machine. Okay, and let's have it like this. And that's the last thing today, my friends. I add another option called equal orange, and I run it and see the results. Now it is